Hey guys, this is Subhash Mishra. Today we will discuss top 25 manual testing interview questions and answers. If you are giving any interview in software testing, then these questions will be very helpful. Please watch the complete video. I have explained everything in detail. Still, if you have any doubt, please let me know in the comment section. I will respond to your query. One more thing, if you are very new to my channel and watching my video for the very first time, please go through the channel. I have created lot of interview related videos on Java, on Selenium, on SQL, on Unix, on API testing, on REST assured API automation. I'll provide all those playlist link in the video description. Go and watch it. If you like it, please press the like button and share it with your friends and subscribe to my channel. Without any other delay, let's start. So, the very first question is, what is software testing? So, software testing is a validation process that confirms that a system works as per business requirements. It measures the overall quality of the system in terms of attributes like correctness, completeness, usability, performance, etc. Basically, software testing is a process to test whether the actual product is matched with an expected requirement or not, and if there is an issue, then it could be resolved before the released product to the market, and at last ensure that the product is bug free. Okay, we'll move to the next question. What is SDLC? Very important question. SDLC stands for Software Development Lifecycle. It refers to all the activities performed during software development like requirement analysis, feasibility study, design, development, testing, deployment, maintenance. Let me explain you in detail about all these steps. The very first thing is requirement analysis. So, requirement gathering and analysis is the most important phase in the software development lifecycle. Product owners, business analysts, and project manager set up a meeting with the customer to gather all the information like what the customer wants to build, who will be the end user, what is the purpose of the product. Before building a product, a core understanding of knowledge of the product is very important. So, that's all we do in the requirement analysis. Then the next thing is feasibility study. Once the requirement analysis phase is completed, the next step is to define and document software needs. So, this process is conducted with the help of SRS document. What is SRS document? SRS document means software requirement specification document. So, it includes everything which should be designed and developed during the project life cycle. There are mainly 5 types of feasibility checks. One is economic. So, here we check can we complete the project within the budget or not. Then legal, can we handle this project as cyber law and other regulatory framework or compliances. Operation feasibility, can we create operations which is expected by the client. Technical, need to check whether the current computer system can support the software. Schedule, decide that project can be completed within the given schedule or not. Then design. So, design has 2 steps, one is HLD, then LLD. HLD stands for high level design, LLD stands for low level design. In HLD, it gives the architecture of the software product to be developed and is done by mostly architects or senior developers. Similarly, LLD is done by the developers or senior developers and it mainly contains the in detail design. So, basically the outcome of this phase is high level and low level design document, which will work as an input to the next phase, which is development. Then we have development phase. So, once the design documents are ready, the developers start writing the code to build the software. Developer writes code using different languages and platforms depending on the need of the product or software. All the components of the software are implemented in this phase. Then we have testing. Once the development is done, software is ready for testing. In this phase, the developed software is tested thoroughly, and if any defects are found, those are assigned to the developers and get fixed. Once the QA makes sure that the software is error free, it goes to the next stage, which is deployment. So, basically the outcome of the testing phase is the quality product and the testing artifacts. Then we have the deployment phase. Once the testing is completed, product is deployed to the production environment and accessible by the customers. Then we have maintenance. Once the system is deployed and once the product is used by the customers, then this maintenance activities started. Like, what are the different maintenance activities? It can be bug fixing, it can be upgrade, it can be enhancement. In bug fixing, if there are any bugs reported, we need to fix it. Developer needs to fix it. In the upgrade scenario, if there are some upgrade required to the existing application, then we will do some upgradation. Okay. Then enhancement, adding some new features to the existing software, that is known as enhancement. Okay. So, all these things happens to the maintenance phase. Okay. We will move to the next question. What is STLC? STLC stands for software testing lifecycle. It refers to all the activities performed during the testing of the software application or product. The different phases are requirement analysis, test planning, test case development, environment setup, test execution, test cycle closure. So, in the requirement analysis phase, the requirement documents or software requirement specification or SRS documents are analyzed. QA team interacts with the different stakeholders to understand the requirement in detail. So, basically QA team defines the scope of testing, identify different types of tests to be performed, gather details about testing priorities and focus, prepare requirement traceability matrix or RTM, identify test environment details where testing is supposed to be performed. Automation feasibility is also evaluated in the requirement analysis phase. Then we have test planning. So, in this phase, the test manager or test lead prepares a detailed plan for testing. So, basically test manager creates a test plan document which includes test tool selection, test effort estimation, resource planning, defining role and responsibilities, training requirement. So, all these things are done during the test planning phase. Then we have test case development. So, once the test plan is prepared, QA team starts designing the test cases, prepares the test data, also prepares the automation scripts, also review the test cases which are already written. Okay. Then we have the test environment setup. In this step, the QA team sets up the software environment based on the hardware and software specifications. If the software is multi-platform, the team will create multiple such environments. Okay. So, this phase can start parallelly with the test case design or test case development phase. Okay. So, once the software system is ready, testers can also perform smoke testing to verify the validity of the environment. Okay. Then test execution. The test team starts executing the test cases based on the test plan. Test cases are marked as passed or failed, and corresponding defect reports are prepared and reported in the bug tracking tool. Developers look at the defects, and if it is a valid defect, they fix it, and again QA team retest and close that defect. Then test closure and reporting. Once all the critical issues has been fixed and tested, testing is almost completed, okay, the test team analyzes the test artifacts like test cases for improvements in the future or other projects. A final test closure report that includes all the test metrics of interest is prepared and signed off. That is your test closure. Okay, we will move to the next question. What is the difference between verification and validation? Verification in software testing is a process of checking documents, design, code and programs in order to check if the software has been built according to the requirement or not. Whereas validation is a process of validating that the developed software product actually meets the exact need of the customer or not. Verification is a static process of analyzing the documents and not the actual end product, whereas validation involves dynamic testing of a software product by running it. Verification is a process oriented approach, whereas validation is a product oriented approach. In verification we make sure that are we building the product right, but in the validation we make sure that are we building the right product. Verification uses methods like reviews, walkthrough, inspections and desk checking. Validation uses method like black box testing, white box testing and non-functional testing. Verification finds bugs early in the development cycle. Validation finds bugs that the verification process cannot catch. In the verification process, the target is application and software architecture specification, complete design, high level and low level designs, database, all these things we target during verification, but in the validation the target is the actual product. QA team does verification and makes sure that the software is as per the requirement in the SRS document that happens to the verification process, but in the validation with the involvement of testing team, validation is executed on software code. Verification comes before validation, validation comes after verification. We will move to the next question. What is static testing? So, static testing is a type of software testing method which is performed to check the defects in software without actually executing the code of the software application. Manual or automated reviews of code, requirement documents and design documents are done in order to find the errors. The main objective of static testing is to improve the quality of software applications by finding errors in the early stages of software development process. Okay, we will move to the next question. What is dynamic testing? The type of testing performed by executing or running the application under test either manually or using automation is called dynamic testing. It includes unit testing, integration testing and acceptance testing. We will move to the next question. What is the difference between static and dynamic testing? So, static testing was done without executing the program, whereas dynamic testing is done by executing the program. Static testing does the verification process, dynamic testing does the validation process. Static testing is about prevention of defects, dynamic testing is about finding and fixing the defects. Static testing gives an assessment of code and documentation, dynamic testing gives bugs or bottlenecks in the software system. Static testing involves a checklist and process to be followed, dynamic testing involves test cases for execution. Static testing can be performed before compilation, dynamic testing is performed after compilation. Static testing covers the structural and statement coverage testing. Dynamic testing techniques are boundary value analysis and equivalent partitioning. Cost of finding defects and fixing is less in static testing. Cost of finding and fixing the defect is high in dynamic testing. In static testing, return on investment will be high as this process involved at an early stage. In dynamic testing, return on investment will be low as this process involves after the development phase. In static testing, more review comments are highly recommended for good quality. in dynamic testing, more defects are highly recommended for good quality. So, that is the major difference between static and dynamic testing. We will move to the next question. When should you stop the testing process? So, deciding when to stop testing can be quite difficult. Many modern software applications are so complex and run in such an interdependent environment that complete testing can never be done. Some common factors in deciding when to stop testing are if deadlines or like release deadlines, testing deadlines are met and no high priority issues are left in the system. Test cases completed with certain percentage passed. When the test budget is depleted, as soon as the automated code coverage meets a specific threshold value, bug rate falls below a certain level, when beta or alpha testing period ends. So, this is when you can stop the testing process. We will move to the next question. What is a test plan? So, test plan is a detailed document that describes the entire testing process to meet the objective of the testing requirements. It is prepared at the project level by test lead or test manager. It is shared with developers, business analysts, project managers and anyone associated with the project to understand the detail of testing. The different attributes in a test plan are like objective, scope, test methodology, approach, assumption, risk, mitigation plan, role and responsibility, schedule, defect tracking, test environments, entry and exit criteria, test automation, effort estimation, test deliverable, template. We will move to the next question. What is a test case? So, a test case is a set of instruction used to validate whether a software application is working as per the requirement or not. A test case has prerequisites, input values and expected results in a documented form that cover the different test scenarios. There are various attributes of test cases that make them more reliable, clear and concise, avoiding any sort of redundancy. So, few of them are like test case ID, test summary, description, prerequisites or precondition, test steps, test data, expected result, actual result, test result, automation status, date, executed by. Okay. So, all these things are part of your test case. We will move to the next question. What are the different test case design techniques? So, there are mainly 3 different test case design techniques we have. One is boundary value analysis, then equivalent class partitioning, then error guessing. So, what is boundary value analysis? So, boundary value analysis is a technique to test boundary value between valid and invalid partitions in test case design. Most of the times errors are observed in the extreme ends of the input values. So, these extreme values like start or end or lower or upper values are called boundary values, and analysis of these boundary values is called boundary value analysis. It is also sometimes known as range checking. Okay. Then we have equivalent partition. So, dividing the test input data into a range of values and selecting the one input value from each range is called equivalent partitioning. This is a black box test case design technique used to calculate the effectiveness of test cases and which can be applied to all the levels of testing from unit, integration, system testing and so on. Error guessing, as the name say error guessing, here tester guess the error and test the application. It is an experience based testing technique where the tester or QA has experience to guess the problematic areas of the application. This technique necessarily requires skilled and experienced tester. The error guessing is more dependent upon the prior experience, intuition and skill of the software tester on similar applications. We will move to the next question. What is smoke testing? So, smoke testing is performed to make sure the build we have received from the developer is stable or not, whether we should able to perform further testing with that build or not. If the build is stable, QA team can perform further in detail testing, otherwise QA team can reject the build with proper issue details. So, the main purpose of smoke testing is to either accept the build and give a signal for further in detail testing, or reject the build with defects, so that QA team does not waste time testing a broken application or product. Smoke testing is a shallow and wide approach of testing. So, in smoke test, we verify critical functionalities of a software is working fine or not. We verify the most important functionality of an application. The aim of smoke testing is not to perform exhaustive testing on any particular component, rather than that, test all the critical components on a high level. For example, if you are testing an e-commerce site, then verify if the website is launching properly. What is the response time? Are you able to log in as an user? Are you able to log out? Are you able to search a product? Check order placement is working or not. So, all these critical functionalities can be part of your smoke test. Okay, let's move to the next question. What is sanity testing? So, sanity testing is performed to validate a particular functionality of an application rather than performing complete regression test for that application. So, we can also say that sanity testing is a subset of regression testing. What that mean? If we have to execute 100 test cases for regression testing of an application, in that case we can execute 20 sanity test cases, and these 20 sanity test cases are part of those 100 test cases. So, in sanity testing, we verify the new functionality or a bug fix has not affected the existing functionality of an application with lesser time and lesser number of test cases. Sanity testing is a narrow and deep approach of testing. So, with sanity test, we test in depth of the new functionality which is implemented or the bugs which is fixed. We will move to the next question. What is the difference between smoke and sanity testing? Smoke testing is a software testing technique that determines whether the deployed software build is stable or not, whereas sanity testing is a software testing technique to validate the new functionality or bugs have been fixed. Smoke testing is a shallow and wide approach of testing. Sanity testing is a narrow and deep approach of testing. Smoke testing is performed by the developers or testers. Sanity testing is usually performed by the testers. Smoke testing is usually documented or automated. Sanity testing is usually not documented and is not automated. Smoke testing checks the overall components of the system. Sanity testing checks the specific functionality of the system. Smoke testing is a subset of acceptance testing. Sanity testing is a subset of regression testing. Smoke testing is like general health checkup. Sanity testing is like specialized health checkup. Now, we will move to the next question. What is functional testing? So, functional testing is a kind of black box testing technique which is performed to confirm that the functionality of an application is working as expected. In functional testing, the application is tested against functional requirements and specification. The common types of functional testings are unit testing, integration testing, smoke testing, sanity testing, regression testing, user acceptance testing. Okay, we will move to the next question. What is the difference between functional and non-functional testing? Functional testing is performed before non-functional testing. Non-functional testing is performed after the functional testing. Functional testing is based on customer requirements, whereas non-functional testing focuses on customers' expectation. It is easy to define functional requirements. It is difficult to define the requirements for non-functional testing. Functional testing helps to validate the behavior of the application. Non-functional testing helps to validate the performance of the application. Functional testing carried out to validate software actions. Non-functional testing is done to validate the performance of the software. Functional testing is carried out using the functional specification. Non-functional testing is carried out by the performance specifications. Functional testing is easy to execute by manual testing. It is very hard to perform non-functional testing manually. It describes what the product does. Functional testing describes what the product does. Non-functional testing describes how the product works. Functional testing checks like the login functionality. Non-functional testing checks the dashboard should load in 2 seconds or 1 second. The examples of functional testing like unit testing, smoke testing, user acceptance testing, integration testing, regression testing, localization testing, globalization testing. Whereas the example of non-functional testing like performance testing, volume testing, scalability testing, load testing, stress testing, usability testing, compliance testing, portability testing. Okay, we will move to the next question. What is the difference between alpha and beta testing? So, alpha testing is performed by internal employees or testers of the organization, and beta testing is done by the users. Alpha testing is done within the organization, while beta testing is done in the user's environment. During alpha testing, only functionality and usability are tested, while during beta testing, usability, functionality, security and reliability all are tested. Alpha testing uses both black box and white box testing techniques, whereas beta testing only uses black box testing technique. Long execution cycles may be needed for alpha testing, while just a few weeks of execution make beta testing possible. Alpha testing answers the question, does the product work, whereas beta testing answers the question, do customers like the product. Okay, we will move to the next question. What is regression testing? Regression testing is a software testing type in which test cases are re-executed in order to check whether the previous functionality of the application is working fine and the new changes have not introduced any bugs. The new changes can be adding a new feature, fixing a bug or updating a current feature in the application. We will move to the next question. What is integration testing? Integration testing is a type of software testing in which the different units, modules or components of a software application are tested as a combined entity. The main goal of this testing is to test the interface between the units or modules. Once all the individual units or modules testing is completed, all the modules are combined and integration testing is performed on top of that to validate everything is working fine. So, there are fundamentally two approaches for doing the integration test. One is bottom up approach, other one is top down approach. We will move to the next question. What is acceptance testing? Acceptance testing is the final level of testing done by a possible end user or customer to see if the software meets the business requirements and can be used. This test determines if the software is ready for production release. We will move to the next question. What is defect or bug? When actual result does not match with the expected result while testing a software application or product, then it results into a defect or bug. We will move to the next question. What is defect or bug life cycle? Defect life cycle is a cycle which a defect goes through during its lifetime. It starts when defect is found and ends when a defect is closed and no one should able to reproduce it. The defect life cycle can vary from company to company and also from project to project based on different factors like organization policy, software development model used like agile or iterative, project timelines, team structure and all. So, here we will see one standard bug life cycle. The very first stage is new, when a defect is logged and posted for the first time. Okay. Then the next stage is assign. After the tester has reported the bug, the lead of the tester approves that bug if it is a genuine one and then assigns the bug to the corresponding developer. Then open. In this stage, the developer opens the bug and start working on it. Then fixed, when developer makes necessary code changes and verifies the changes, then he can mark the bug state as fixed, okay, and pass to the testing team. Then pending retest. In this state, the developer has given the fix, but tester has not started testing it, okay, hence the testing is pending. So, the state is pending retest. Then the retest, at this stage the tester do the retesting of the changed code which developer has given to them, okay, and verify whether the defect is working fine or not. Then verify, once the tester verify the bug, everything is working fine, then they can mark it as verified. Reopen, if tester founds that the bug is still exist, then they can reopen the bug and again can assign the same bug to the developer. Then closed, once the bug is fixed, everything is working fine, then tester can close the bug. If no work is required in that, then they can close that bug. Then there are some more steps like duplicate. If the bug is repeated twice or the two different QA members have raised the same bug, then it can be a duplicate one. Rejected, if the developer feels that the bug is not genuine, then they can reject the bug. Then deferred, if that bug is not very important for that particular release, if it is getting deferred to the next release, then the status can be deferred. Okay. Then not a bug, if the changes asked in that particular bug are not valid, then it can be a not a bug. Okay. Then we will move to the next question. What are the some of the bugs or defect management tool? Okay. So there are different defect management or bug management tools like Jira, Quality Center, Bugzilla, Redmine, Mantis. We will move to the next question. What is the difference between defect priority and severity? So defect priority means what is the priority or urgency to fix the defect. Severity means how severe or critical the defect is for the product. Priority is set by developers, severity is set by the testers. Priority is categorized into 3 types: low, medium and high. Severity is categorized into 5 types: critical, major, moderate, minor and cosmetic. Priority is driven by the business value, severity is driven by the functionality. Priority value is subjective and can change over a period of time depending on the change in the project situation, whereas severity value is objective and is less likely to change. Priority status is based on the customer requirements, whereas severity status is based on the technical aspect of the product. We will move to the next question. Give some examples of low priority, low severity, low priority, high severity, high priority, low severity and high priority, high severity defects. Very, very important question. You may get this question in your interview. Okay. So, the example of low priority and low severity, a spelling mistake in a page which is not frequently navigated by the users. This is a low priority bug because users do not navigate to that very frequently. Also, it is a low severity because it's just a spelling mistake, it is not breaking any of the application. Low priority and high severity, application is crashing in one of the corner case. This is low priority because it is in the corner case scenario, but high severity because the application is crashing, the functionality is breaking, that is why it is high severity but low priority. Then high priority and low severity, slight change in logo color or spelling mistake in the company name. So this is high priority because logo name, company name, these are like the brand values. It can affect the brand value, right? It can affect the business. That's why it needs to be fixed as early possible. But functionality wise, if you will see, it has no issue. That's why it is low priority. Then high priority, high severity, issue with login functionality. If login functionality is not working means you will not able to do any operations. That's why it is high severity and high priority. Functionality wise it is breaking, that's why it is high severity, and it is very, very important to get fixed because without that we cannot work on anything else. That's why it is high priority and high severity. So that's all for today. I have explained you 25 manual testing interview questions and answers. I hope this video is helpful for you. If you like this video, please press the like button, share it with your friends, and do not forget to subscribe my channel. Thank you so much. Bye bye.